In 8-2, we're using our division properties of exponents. This is on page 486 in the textbook. Okay, there's two division properties, and then this section also has the zero property, so that'll be this 3a and 3b, and the negative exponent property. So all four properties that are left on your flip chart are in section 8-2. So let's just start in. The first property says that when you have like bases, if you're dividing, you subtract, which makes sense because if you have like bases multiplying, you add. So dividing, you subtract. X and X are my like bases, so I'm going to do X3, and there's two of them here, and so this would give me X1, and then 4 minus the 1 down here gives me Y3. Now, you can also expand these out and cancel out. So if I have 3 X's, 4 Y's, and then on the top I have 2 X's and 1 Y, the X's will cancel here and cancel here. So you're left with 1 X, which is what we had, and this Y will cancel. You're left with 3 Y's, which is what we had. So this is the long way to do it, but you can do it this way. It'll just take longer than subtracting like this one, especially if you get many, many letters, like it gets more complicated later. So here again, we have k to the 7 and k to the 5th. So this would be k to the 2 because 7 minus 5 is 2. M to the 10 minus 3 is going to give you m to the 7. And then this is p to the 1 and p to the 1 power. So 1 minus 1 will give me 0, and these will essentially cancel out or equal 1. Okay, so my final answer here is k squared, m to the 7th power. Numbers 2a and 2c are going to combine the first property and the second property. The second property is very similar to the one that we saw yesterday. Second property, or today I guess, in 8-1. So this says that if you have a 3 out here, it's going to go to every factor inside the parentheses. So not only the top, but also the bottom. So there are 3 factors. There's 1 factor here, 1 factor here, and 1 here. The 3 is going to go with all 3 of them. So I'm going to rewrite. It will give me 3 to the 3rd power, x to the 4th to the 3rd power, and 4 to the 3rd power. Okay, so if I expand that, the numbers 3 to the 3rd power is 3 times 3 times 3, which is 27. This, remember, has a parentheses and an exponent outside, so this is our multiplication one. 4 times 3 is 12, so I have x to the 12th. And then on the bottom, 4 to the 3rd power is 4 times 4 times 4, which would give me 64. And I think that I'm finished here. Now, go ahead and put 27 divided by 64 in your calculator to make sure that you can't simplify this, because if the fraction can be simplified, you also have to simplify. So I'm going to leave it like this and hope that it's simplified since I don't have a calculator. Okay, so here, again, there are 1, 2, 3, 4 parts or factors. And so I'm going to go 2 for all 4 of them. So I'm going to say 2 squared, y squared squared, 3 squared, and z3 squared. Then I'm going to simplify. 2 squared is 2 times 2, which is 4. This has parentheses and an exponent outside, so this is my multiplication rule. 2 times 2 is 4 again, so I have y to the 4th, over 3 squared is 9, 3 times 3. And multiplying these exponents would give you z to the 6th power on the bottom. Okay, there's no like bases anymore, so, and this 4 over 9 cannot be simplified, so I'm finished with this problem. So here on 3a and 3b, we move to the zero property. So it's going to combine division and the zero property. The zero property is very, very easy. All it says is that when you have an exponent of 0, it equals 1. The whole thing equals 1. So it was similar to what we did up here. 1 minus 1 gave us p to the 0 power technically, but p divided by p is the same thing as 1. So anytime you have something that has an exponent of 0, it would equal 1. So in this problem, I have like bases here, so I can subtract these exponents according to my first subtraction rule, the quotient of a power. So 4 minus 2 would give me b to the 2. C2 and C1, I'm going to subtract 2 minus 1 and just have 1c. And then the d to the 0 power here, that would make this whole thing equal to 1. And so I don't really need to put it because anything times 1 is the same thing as itself. So this would be my final answer. And 3b, same concept. This makes this very, very easy because the whole thing is to the 0 power. So the whole thing just equals 1. Okay, so sometimes it's in the middle of something, and so it would just equal 1 in the middle, but you would still have other parts that don't equal 1. I'm sorry, not 0, 1. But sometimes it's the whole thing to the 0 power, so the whole thing would equal 1. The negative exponent rule is a little trickier. It says when you have a negative exponent, if it's in the numerator, you flip it to the denominator or move it to the denominator and it becomes positive. If it's in the denominator, you move it to the numerator and it becomes positive. So the first thing I usually do is make all my exponents positive before I start subtracting or adding or anything like that. So I'm going to make this one positive. Right now it's negative, so I need to move it to the denominator. This one is negative, so I need to move it to the numerator. The w and the x2 and the w and, don't need to be moved. They're just going to stay where they are for now. So I have the y up at the top, y to the positive 6 now, because when we move it to the top, it becomes positive. We have a w at x squared, and then in the denominator, I have the v to the third, a w, and that's it. Okay, so the only like bases that I have are the w's, and there's one on the top and one on the bottom, so they equal 1 and they cancel out. So my final answer is y6 x2 over v3. For b, the numbers in the front are just numbers. So if it says, if I have 32 divided by 4 without all the letters, it would just be 8. It's the same thing here. 32 divided by 4 just gives me 8. So my answer for the number part would be 8. I'm going to move things around at this point. Actually, I should have done that first. So I'm going to move this one down, this one down, and this one up. So when I move them up or down, I have 32, B3, C positive 2, and that's it because the other two moved down. And then in the denominator, I have 4, A3. This A moved down, so now I have A8 also. And the C, B5. And the C also moved down, so C4. Okay, and now I can do my adding and subtracting and multiplying and whatever. So 32 divided by 4 gives me 8. The A's are all in the denominator, and I have 11 of them, so I'm going to go ahead and do a fraction here. I have A to the 11th power. The B's, I have 3 up at the top and 5 on the bottom. So I could subtract and I would get -2. So really, the easiest way to think about this is there are only 3 on the top and there are 5 on the bottom. So these two and this one and this one, I have 2 left in the bottom. So b squared in the bottom. C's the same thing. I have 2 at the top and 4 on the bottom, so I'm still going to have 2 in the bottom after I divide. So this 8, I'm actually going to put it in the middle. And this would be my final answer. 8 over A11, B2, C2. Last one, moves to the bottom, moves to the bottom, moves to the top, and moves to the top. So moving things, I have 5, K2, K4, bottom, and M2. On the bottom I have 25, and I have J3, and I have M6. Okay, so 5 over 25 simplifies to 1/5. I have 2 and 4, which gives me K to the 6th on top. Since these are being multiplied, I add. The J3 stays on the bottom. The 2 minus the 6 means I have 4 still left on the bottom. So I don't really need this 1. I can keep it K to the 6th over 5, J to the 3rd, M to the 4th.